Hello, today we're going to be talking about exploring bivariate numerical data once again and scatter plots. But today what we're going to talk about are the correlation coefficient, and then you'll be able to practice on Khan Academy. Yesterday you should have been able to complete constructing scatter plots, positive and negative linear associations from scatter plots, and describing trends in scatter plots on Khan Academy. And I noticed that we did very well with that, so excellent. Today we're going to talk about how strong the relationship is between two variables. And so we call that the correlation. When two sets of data are strongly linked together, we say they have a high correlation. The word correlation is made of the word co, meaning together, and relation, meaning how one variable affects the other. And so a correlation is positive when the values increase together. So as x increases, y increases as well. And the correlation is negative when one value decreases as the other value increases. And it looks like this. So a 0 is what we call no correlation. You saw examples of that yesterday when you were looking at trends in the data. It almost looks like it's snowing outside. You'll see dots everywhere. You can't really determine that there's any relationship between the two. An example of this would be like your intelligence is related to your shoe size. People with larger shoe sizes are more intelligent. That's just not the case. And then you go down as the correlation becomes more and more negative. The closer it is to -1, -1 is actually a perfect negative correlation. And then as the correlation increases, 1 being perfect positive correlation, that would be like a linear graph. A 0.9 would be a very high positive correlation, and a 0.5 would be a low positive correlation. You can see that you could see the trend is trending up. However, the dots aren't very close together. They aren't making a perfect line as they do in 1. And so these numerical values actually show how good the correlation is, not how steep the line is. Obviously, how steep the line is your slope. And so they also tell you whether the relationship is positive or negative. So if I said something had a 0.75 correlation, it would be somewhere between 9 and 0.5. So the dots would be relatively close to making a straight line, but they'd be a little spaced apart. If I said something had a negative 0.2 correlation, that would be here between 0 and 0.5. So as you can see, the dots would be, the dots on your scatter plot, your data points, would be spaced out, but you could kind of see a trend in that the data would be kind of going down. So you can think of some examples that you looked at yesterday that would relate to this. All right, so how do you calculate your correlation coefficient? Well, for this example, you are going to need your calculator. So go ahead and pause the video if you need to go and get your calculator. Now that you have your calculator, what you are going to do is you're going to enter this information into your lists. So in order to do that, you click Stat, Enter, and you're going to highlight L1, hit Clear, Enter, and then you can start entering all the data for the temperature in degrees Celsius. Then you'll scroll over to L2, highlight L2, hit Clear, Enter, and you can go ahead and enter all the data for ice cream sales. Once again, you're going to want to pause this video and go ahead and enter that data in so that you are practicing how to use the calculator to calculate your correlation coefficient. This is just simply a calculation. It's very similar to standard deviation. It is a lot of steps. So you want to make sure you're using a calculator or some kind of technology to do this because it's just too many steps to do on your own. So go ahead and pause the video, enter your data. All right, now that your data is entered, you're going to hit the Stat button, and then you're going to scroll over to Calculate, hit 4, enter. And what you should see is The symbol is LIN, capital REG. It's basically going to be your equation for your regression line, which we're going to talk about tomorrow and the next day. And you should notice that it says y equals ax plus b. That's slope-intercept form. So essentially we're going to define a line that meets most of the data point. So we're going to kind of predict data using a line of best fit. Once you have your regression line, now you can go back and hit vars, which you'll see, and then you're going to hit 5, which is statistics, and then scroll over to EQ at the very top, and then hit 7. The symbol that we use for the correlation coefficient is the R, the little lowercase r. That is another way of saying correlation coefficient. And then you're going to hit 7, hit enter, and you should get 0.9575. So if you look at this data, the correlation coefficient is positive. It's 0.9575. If we go back to the previous screen, we can see that that is a very strong positive correlation. So we could say that definitely as temperature increases, we can definitely say for certainty that the sales of ice cream is also going to increase. So there's definitely a strong positive correlation between temperature and ice cream sales. All right, let's move on. Correlation is not very good with curves. The correlation coefficient is excellent for determining the strength of the association between linear data, but if you have a curve in the data, though this is a strong non-linear association, you can't really put a number on it. So if we put every single one of these data points into our list, again, temperature would be one of our lists and sales would be the other. When you actually calculate it out, if you would like to do that, you may. Just go ahead and pause the video, and you'd have to kind of estimate that this would be like 12, 195. This one would be maybe 14, 205. This data point might be like 16 and 310. So you can estimate and put the numbers in every single data point, going up the curve and coming back down to see. And what you'll notice is that the correlation is actually 0. So if you did put it in, which means there is no correlation, but you can actually see that there is a correlation. It follows a very nice curve. You can see that right here. It almost looks like the normal curve that we talked about in last unit. And then we can see definitely that there's a peak right here around 25. But the linear correlation calculation that we use to calculate the correlation coefficient is just not smart enough to see this. So the moral of the story here is that you should always make a scatter plot. You can't just rely on the correlation coefficient to tell you how strong the relationship between the data is. You should always kind of make a scatter plot so you can see for yourself how strong the correlation is. I just want to show you that's a good example. Correlation is also not causation. So what do I mean to say is that there could be other reasons why the data has a good correlation. So for example, let's say that we're looking at our ice cream sales example, and instead of comparing ice cream sales to the temperature outside, we say, oh, well, a ton of sunglasses were sold. So as the number of sunglasses sold increases, so does ice cream. So it must mean that people, when they buy sunglasses, they're like, oh, I should go get some ice cream as well. But does that really mean that when you buy sunglasses, you also want ice cream? Could there be another reason why sunglasses being sold is increasing along with ice cream sales? And again, that would probably relate to temperature. As the temperature increases, the sun tends to be brighter. People want to buy sunglasses, and they also want to buy ice cream. So though this is, again, a strong positive correlation, as the sale of sunglasses increased, so did ice cream. Can we really say that the two are related, that one relates to the other? So you kind of have to ask yourself those questions as well. Data is numbers, and numbers are nothing without an explanation. Here's another example of a case that happened a few years ago. What they noticed is that when they took a survey and when employees that were also taking classes outside of work, like say they went to UT for some night classes, and what they noticed is that people that were studying an external course, so taking extra classes at the University of Tennessee, had an increase in sick days. And so the question is, does that mean that studying was making them sick? Does that mean that sick people study a lot? Or could that maybe mean that people were calling out sick because they needed to have more time to study? So though there was a strong correlation that people that had the external course, the more that they were in an external course, the more sick days they were taking at work, we'd have to further research to find out which question could this possibly relate to. So there are 3 practice problems on the back side of your worksheet. And again, you're going to need to calculate the correlation coefficient. For some of them, you'll have to also draw the scatter plot and calculate the correlation coefficient. So let's go back and review. How do you calculate your correlation coefficient? Again, it is going to tell you how strongly related the data points are, whether they're positive or negative. And you calculate it by entering the data in a list. You're going to need an L1 and L2. And then you hit Stat Scroll Calculate 4. That'll give you the equation for the line, the linear regression line. And then you use that to calculate the correlation coefficient, how related those two are. So again, you're going to need this information to answer the 3 practice problems on the back. When you have completed your 3 practice problems, we will discuss them, and then you are to complete Khan Academy. It's called Correlation Coefficient Intuition. Essentially, they're going to be, well, I'll show you an example. Okay, so once again, when you're in, you're going to go to Statistics and Probability. We're doing Exploring Bivariate Numerical Data, and we're talking about correlation coefficients here. So you click on that, and it's Correlation Coefficient Intuition. And basically what you need to do is estimate. So if I look at scatter plot A, I know it has to be negative. And so my choices are negative 0.75 or negative 0.41. So I'm going to look and see. This appears to be the other negative scatter plot. So I have to compare this to. This one is much stronger than this one. So I'm going to go ahead and flip-flop this one, put here. And scatter plot B, I believe, is negative 0.41, excuse me. And then I'm going to look at scatter plot C and D. And again, C is a much stronger positive linear association than scatter plot D. So I'm going to go ahead and, let's see, leave it like that. And then I'm going to cross my fingers, and yay, I got it. And so that's what you're going to do for at least 4 of 7 problems on Khan Academy. So again, complete the 3 practice problems on the back of your notes, and then you're going to match the correlation coefficient with the correct graph on Khan Academy. Good luck!